I'm happy that you could join us for Advanced Broadcast Technology. I'm your co-host, Lidia Paulińska. Today we will be presenting the first of a series of educational talks that will cover basic issues and current trends for the broadcast and studio production. I'm pleased to welcome my co-host, Pallab Chatterjee, who will be introducing today's speaker.
Thank you for the introduction, Lydia. I'm your co-host, Pallab Chatterjee. Today, we're pleased to have Chris Countryman, president of Countryman Associates, to talk to us about microphone technology. He'll be overviewing the types of microphones that are available, how to read and understand the specifications, and then most importantly, understanding the applications of the different microphone styles that are available on the market for use at events, in offices, and in a studio. Hope you enjoy the information.
Hi, I'm Chris Countryman. I'm with Countryman Associates. We're a microphone manufacturer based in the San Francisco Bay Area. We make probably 35,000 different styles and types of microphones, so I have a lot of sympathy for people who are trying to navigate the universe of microphone options and figure out what is going to work best for them. So I have a short presentation where I'll walk through some of the basic microphone technology and terminology, and then microphone specifications so that you can cut through marketing and get right to what's important so you can make decisions for yourself about microphones. And then I'll end with the kind of most popular styles of microphones and some of the applications that you'll find in the studio and on location. So right now there are 4 main microphone technologies that are being used. The one that people are probably most familiar with is the moving coil microphone. That's a coil wrapped around a magnet, and that coil is attached to a diaphragm. When the diaphragm is impinged by sound, it moves the coil relative to the magnet, and that creates an electrical signal. Ribbon microphones are also popular, an older style of microphone. It's a metal ribbon that does essentially the same thing. Very new microphone on the market is the MEMS style microphone. These are microphones that are made with the same technology you'd use to produce computer chips. Little etched membranes are separated by just a tiny fraction of an inch, and sound will move the membranes relative to each other. It's actually a variable capacitor, and so that changing signal is amplified and used to make an audio output. And then the style of microphone that we work with most is the condenser microphone. Similar to the MEMS, it's 2 plates that are moving relative to each other, and that creates the microphone output signal. Now, it's not so critical that you understand all of the technology or get deep into the details, but you should be familiar with the terms that people use to describe these microphones so you won't be bamboozled, and that you can really understand what's most critical, what are the sort of performance specifications, and how will the microphone work well for you. I'll get right into a couple of characteristics of microphones that you should be aware of before we dive into specs. Like heat from a bonfire or light from a light bulb, the intensity of sound follows the inverse square law. So as you double the distance from the source to the microphone, you're only getting 1/4 of the sound energy. So that sound energy drops off very rapidly, and it's something that people often don't have a good intuitive sense for. The big takeaway is to keep your microphone as close to the source as possible so that you can turn the gain down and get good isolation from surrounding sounds. The other thing that's really important to understand about microphones is that they are vibration sensors. So they are tuned to pick up the tiny air vibrations that are your speech through the air, but they will also happily pick up any other vibrations. That could be pounding on a table, wind noise, vibrations of a cable rubbing inside of clothing. And these are much, much larger signals than the air vibrations from speech. So a lot of energy and effort on the microphone manufacturer's part is used to try to eliminate that from the signal. And also when you are using these microphones, you should take care to make sure that you're getting just the sound of your voice and not vibrations from whatever other sources are around. So to dive into microphone specifics and specifications for just a minute, probably the first and most important one to understand thoroughly is sensitivity. So how much output do you get per unit of input on a microphone? And that could be specified in millivolts per Pascal of sound pressure. An alternate system is dB relative to 1 volt per Pascal. So a typical lavalier microphone might be 10 millivolts per Pascal. That would be minus 40 dB relative 1 volt per Pascal. There's a particularly nice job of specifying the sensitivity from this manufacturer's datasheet. You will not always see that level of care taken, so read these datasheets, and I'll show examples as we go through with a grain of salt. But the nice thing about sensitivity right off the bat is that if you can start to get familiar with the range of sensitivity that you can see in different styles of microphones, you can get a sense of the intended application. So a microphone in the sort of 10 millivolt per Pascal range is probably intended to be a lavalier style, kind of worn near to or a little bit away from the body, whereas a microphone that was 1 millivolt per Pascal or minus 60 dB relative to 1 Pascal is much less sensitive and could be used much, much closer to the source. So you might find that in a headset or an ear set or something like that. So now that we know sensitivity, we can talk about how sensitivity changes relative to different frequencies. So does this microphone pick up low frequencies more or less than high frequencies? And we show that as a microphone frequency response curve. So in this case, the microphone has a little bit of roll off in the low frequencies, and then it kind of picks up again. There's a small presence boost higher up, and this is really a matter of taste to some degree. Some people would want slightly boosted low end microphone for kind of to fill out the low end of the vocal range, kind of the smooth jazz DJ sound, or you might want a little bit of an extra presence, a little bit of a presence boost in the higher frequencies. That might help you make up for a microphone that's being muffled under clothing, as a lot of microphones are hidden on the body. If the microphone picks up all frequencies equally, then that line on that plot would just be completely flat. And that's actually a very nice, natural, even sound, and is a really good starting place. I think some people, it's much easier to add something or take it out at the mixing console or in post-production than it is to start with something that has a lot of color to it, that's really a very unusually shaped frequency response curve, and try to work with that in post-processing. So the flat microphone with a natural frequency response is an excellent kind of blank canvas to start from. Polar pattern is the next specification that I want to talk about. So this is just what is the sensitivity relative to the angle of the source. And an omnidirectional microphone would have a plot that would be a perfect circle. You can imagine looking down on the microphone with the microphone pointed towards the top of the screen in this diagram. A cardioid microphone, kind of on the upper row there in the middle, that is a microphone that rejects maximally from the rear. So as that curve on the plot dives into the center, that's indicating that the microphone is least sensitive from that direction. And there's a whole family of these. We call them the first order cardioid patterns, supercardioid, hypercardioid, bidirectional. Those are all patterns that have increasing rejection of ambient sound and have their nulls, what we call the area of maximum rejection, kind of moving out from the back towards the sides. And that last pattern that I have there is a low bar pattern. It's kind of one example of a whole range of patterns that you can get out of microphones like parabolic microphones and shotgun microphones. We'll talk a little bit about that type of microphone later. This is a very, very focused microphone, but the thing that you should take away from polar patterns is that it's not focused the way a flashlight is. Think of a microphone as more like a pair of noise-canceling headphones. All the microphone is able to do is cancel out surrounding sound. It can't make your source louder. So in all cases, you really need to be kind of cognizant of the distance from your source. You can't get around that inverse square law. You need to be able to work with a microphone close to the source. Next specification I talk about is equivalent acoustic noise. This is the signal that comes out of the microphone when there is no sound source. It's essentially what sound level is equivalent, what sound level would you need to have to make your microphone produce that electrical output. And this is a very important specification. You're always going to want to minimize it to the extent that that's reasonable. If you are in a well-controlled environment like this studio, then you would want a microphone with a very low noise floor, kind of in that 10 to 20 dB range would be very appropriate, because you wouldn't want to have a microphone that was artificially raising the noise in your environment. If you are out on location in a place that's very, very noisy, you may have the ability to be a little bit more flexible with your the noise floor on your microphone. I've got a couple of specs from manufacturers here just to kind of give you a range. The top plot is a shotgun microphone. It's very sensitive. You'll notice it's intended to be used a little bit further away from the source. And then we've got a lavalier microphone that's on the chest, kind of a similar sensitivity range, and a headset microphone. well, this manufacturer didn't actually provide any information on that specification, and this is where you have to be really careful. The quality of the data varies really dramatically, but again, if you start to look at these specifications in concert, you'll get a feel for both the quality of a microphone and also its kind of intended application. Last, I would talk about overload level. This would be the maximum signal that you can get out of the microphone, or the maximum sound level that you can get before the microphone starts to distort the signal. This is probably one of the hardest specifications to really talk about apples to apples, because microphone manufacturers are notoriously bad in terms of being consistent about specifications here. So, when we specify our microphones, we do that at 1% total harmonic distortion. So that's the sound level at which you are distorting the sound by 1%. Generally considered to be kind of the threshold of noticeability. But other people will choose 3% distortion, 5% distortion, or they may not specify anything at all. They may simply specify clipping, at which point your sine wave is starting to become a square wave. Your sound has long since been more or less unusable. So this is something to take with care and caution, but it is useful for understanding, again, is this a 150 dB SPL overload microphone maybe intended for an instrument, or is it down in the 100, 120 range, where it would really be the kind of microphone that you might only want to use for speech rather than singing. So now that we kind of understand the specifications, let's talk a little bit about which ones are important for various different kinds of applications and styles of microphones. So in the studio, you might be familiar with these kind of voiceover style microphone. Typically, these are ribbon microphones or large diaphragm condenser microphones, but they really can be of any style. They're typically large, and when you're in a studio environment and you're able to control things, you would want to really think about having what's the appearance going to be like on camera? Is this going to be something that's attractive, or if not attractive, at least very small? Is it going to be something that's, because it's close to the mouth, some people are speaking directly into it, and possibly untrained talent, you may want to prioritize a high overload level. Low noise floor is always going to be nice, but particularly in the studio where you've got a low noise floor in general. You're going to want to make sure that there's some kind of system for handling vibration noise, because if it's going to be interacting with talent, they may touch it, they may move it. And then almost always you will want either a windscreen or some type of pop filter, because breathing directly on the microphone is going to be a no-no. The last thing to think about here is choosing a suitable polar pattern for this microphone. A popular choice would be cardioid, or perhaps something a little bit more focused, like a supercardioid or a hypercardioid. Think about the distance that the microphone will be from the user and how much you expect them to move their head around or move their body around, what kind of area you need to cover. And that'll give you a good sense of the microphone that's going to be right for you. Body-worn and head-worn microphones are kind of a specialty of our company. We make some of the smallest in the world. You can see the woman on the left, the same woman, she's wearing a lavalier microphone on the left, and you can probably just see it pinned to her blouse. And then on the right, you'll see she's got an ear-worn microphone. We call them ear sets, and they're very, very small and discreet, designed to match skin color. The main advantage of ear-worn microphone is that you can get it much, much closer to the source. So I'm wearing a lavalier in this video presentation. If I had an ear set microphone on now, I could get probably between 10 and 20 dB more isolation, because I could turn the gain down and get cleaner audio, stronger signal. It's a very versatile microphone, especially in a situation where you don't necessarily have a lot of time or control over your environment. Critical features for both lavaliers and ear sets would be small size. They're going to be visible on camera, so they need to be as discreet as possible. Extremely rugged. Anything that's going to be worn on the body or used by the talent directly has to be very tough. So, we make microphones with Kevlar reinforced cable. A lot of people are doing something similar because the microphones have to survive rugged use in the field. High overload is going to be critical if it's a microphone like an ear set microphone. It's right next to the mouth. Sound level is extremely high, even just for speaking. And you'll need to be thinking about breath noise, positioning the microphone, and wireless compatibility is also really important. I'm wearing a wireless transmitter right now. There are hundreds of active wireless transmitters, and you'll need a connection for your microphone that's equivalent for that microphone transmitter. Lastly, I would say think a little bit about polar pattern here. Because you're so much closer to the source than you would be for any of these other styles of microphone, Often you can choose an Omni microphone, which has some distinct advantages. The Omni microphones have less handling noise than their directional counterparts, and they're less sensitive to wind and breath. So this is an excellent place where the inverse square law really works in your favor. And then hanging microphones. Some studios have strung wires and lines, and they have microphones hanging in the space to give kind of area coverage. It's very, very popular for theaters, sometimes for audience microphones in live studio environments, where you don't have to directly put a microphone on a person. You can just kind of get a series of microphones in a line or in several rows and get good coverage of the entire space. Critical things here, again, visibility. If you have a small microphone, then you can get a lot closer to your source without it being a distraction. And then you'll need to be thinking about frequency response. This is a case where you really do want to have an excellent microphone that doesn't color off axis, because people will be moving around in the space and you want to make sure that your microphone stays consistent across its whole polar pattern. And then it's really important to think about how many microphones you will need and where you'll need to place them to get that even coverage. It's sort of a trade-off between polar pattern, isolation, number of microphones. It's a great opportunity for you to reach out and contact a local distributor or dealer or talk to a manufacturer to get a sense for it, because it's very individualized to the space. Lastly, I'll talk a little bit about shotgun microphones. These are microphones that have very directional patterns, like that low bar pattern that we saw, kind of starting with hypercardioid and moving into that low bar space. You can see an example of a shotgun microphone mounted to a camera on the left, and then there's a shotgun microphone mounted to a boom pole and being held above talent on the right. This is a case where you're going to be probably farther from your talent, although you'll see not that far, maybe a couple of feet, but you'll want high sensitivity for this application and a directional pattern that really gives you just the subject you're interested in. Low acoustic noise is important in this case too. You'll definitely want to be a well-controlled pattern. A lot of microphones, when you get off axis, meaning if it's a directional microphone that's picking up from the front really well, as you move around to the side, and especially as you dip into those null regions, the frequency response will change. That means that the sound won't sound natural coming off axis. It'll be reduced in volume, but it won't be evenly reduced in volume. So you may sound a little bit like you're underwater, or you may get kind of a strange, they call it coloration to the sound. So that's something to be careful of with these microphones in particular, because almost all shotgun microphones suffer from that kind of poor pattern control to a greater degree than other styles of microphones. And I would say finally, be realistic about the distance. In the microphone manufacturing world, we talk about a distance factor. So if I get good audio from an omnidirectional microphone at a foot, let's say, I could get a cardioid microphone and move back to 1.7 feet and turn the gain up, and I would get the same relative background to my source. So I could move 1.7 times further back and still manage to capture that same kind of quality of audio. A hypercardioid would let you move to 2 feet. A shotgun microphone might let you move to 3 feet, but that's still just 3 feet. I think a lot of people who are working with shotgun microphones magically think that they could move to 10 feet or 12 feet and be able to capture anything reasonable. You cannot beat the inverse square law. So try to always stay as close to the source as possible and use this style of microphone really judiciously. It's a little bit of a specialist tool and it requires some careful planning and training. So that's my presentation. Thank you very much for the time.
The presentation by Chris at Countryman Microphone gave an overview with the microphone basics on selecting and understanding microphones. Some of the basic connections and interface guidelines for these microphones will now be presented. The first point to understand is that microphones, as described so far, are analog devices that return a continuously changing electrical signal output level based on the sound air pressure that is received at the sensor of the microphone. The default direct connection plug for the professional microphone is a balanced signal that is a small difference signal, not a digital ones and zeros pattern. The balanced signal is most often carried over a wired connection to an XLR jack. This is a 3-pin connection and supports a latching male or female plug, and is also supporting a panel mount male and female version socket. For most applications, the microphones have a male connection. These use a standard microphone cable that has a male connection on one end and a female connection on the other. The male end of the cable typically connects to a preamplifier that helps isolate the signal and compensate for signal loss along the cable. The XLR connection is standardized with pin 1 being ground, pin 2 being the signal or hot connection for the microphone, and pin 3 being the balanced signal reference or cold connection. As the connection is keyed in orientation with the latch, they cannot get hooked up with the wrong pin connection. In addition to the data signals from the microphone, most microphones are passive devices which need a power source to have them operate and create a gain in the electrical signal from the sound sensor itself. This power is called phantom power and is a plus 48 volt with respect to pin 1 voltage that allows the signal from the microphone pickup to be amplified to be measurable. Most studio targeted microphones need the phantom power on the microphone connection. Wireless microphones and USB microphones receive this power from either the local transmitter connected to the microphone or from the digital circuitry that creates the analog to digital conversion for the USB data output. Both the wireless microphones and the USB microphones tend to have built-in preamplifiers to enhance the signal locally before it is being transmitted. The higher voltage of the phantom power and the sensitivity of the balanced differential signal means a high-quality cable must be used. XLR connectors are found at the end of coaxial cables, also known as coax. There are 3 dominant types in the audio industry: RG58, RG8, and RG213. The construction of the cables is similar, but the need for short and long run lengths require the selection of different cables. The cables have a range of signal loss, typically given in a specification that is loss per 100 feet, and help determine what sort of microphone technology and what sort of preamp is to be used to process the signal. With the advent of smaller cameras and smaller recording devices, a new connector with a smaller form factor is available. It looks like a standard headphone connection and fits the 3.5 millimeter form factor. The plug is also known as a mini plug or mini DIN plug, but it is technically referred to as a TRRS connector. The name is for a 4-terminal connector and refers to the pins of T for tip, R for ring, R for ring, and S for sleeve. It is the connector for most smartphones, DSLRs, tablets, and small format video cameras. The TRRS connection is an unbalanced microphone connection, so it is different from the XLR signal. One of the big areas in selecting designs is for wireless. Just like with microphone patterns, the antennas of the transmitter and receiving systems also have shapes that impact their ability to pick up a signal. This means placement and interference from other wireless devices are a big part of determining the quality of the sound that comes out. There are a couple of basic antenna shapes that dominate the wireless microphone industry: the half-dipole antenna and the log periodic antenna. These antennae have fairly wide patterns for pickup, but more importantly, they select from a large frequency range. Many applications will have multiple microphones present. For a musical event, it is not unreasonable to have over 50 microphones operating at one time. These antenna designs allow for the antenna as a standalone item to be connected to a range of receivers in either the VHF or UHF signal band. For the first time in over 40 years, the frequency bands for microphones is changing. The FCC Spectrum auction has resulted in new overlaps and exclusive areas for people operating unlicensed wireless devices such as microphones. The chart shows the realignment that is planned for taking effect in 2020. The realignment will not affect the need for events and venue performances to still need an FCC Part 74 license when operating 50 or more wireless devices. This includes microphones, communication headsets, wireless video feeds, wireless recording devices, and wireless broadcast to internet bridge devices in a single location. While the 50 device count historically has limited the need to large venues such as stadiums, now with mobile technology, the device limit is quickly reached due to the availability of wireless cameras, mixers, recording devices, headsets, microphones, routers, and gateways. So a count of 50 devices is easily reached with gatherings as small as 12 people or a 5-person production with a 2-camera team. In all microphone setups, whether in the field or in the studio, wired or wireless, The most critical step of the setup process is the sound check. Environmental conditions are constantly changing, and verifying that the power is on and the correct cable goes to the correct bank of connection and is plugged into the correct channel to be recorded is paramount. One of the new areas of products is for 360 video and virtual reality. In these applications, surround sound is needed. Playback of these surround sound environments range from systems that are 2-speaker stereo, 5.1, 7.1, 11.1, 22.2, and higher speaker arrangements. To record these sounds, microphone pods and clusters are being used. These microphones come in several mechanical styles and designs. The microphones are all separately connected with XLR connections. The examples include the Holophone Pro 7.1 surround sound microphone, the Sennheiser Ambio VR mic, the Eigen mic, and the Canon 5.1 surround microphone for portable camcorders and DSLRs.
So thank you very much, Chris. That was an enjoyable talk and very understandable. I have a couple of questions that have come in from some of our listeners and other people we've been talking to. The first thing is, you showed in one of the slides about the hanging microphones. And I've noticed that that's one of the common structures that people are using in conference rooms and attempting to record those conferences for going forward. What do people have to keep in mind with the patterns on the microphones and things for using it in an office type environment?
It's a great question. Hanging microphones are, you're absolutely right, very, very common in these kind of conference situations. Things to keep in mind with a hanging microphone. In a conference room, sources of noise are going to be things like ceiling fans, air conditioning ducts, that kind of stuff, rustling papers on the table. Because the microphone is not amplifying the sound, a directional microphone's only rejecting as much of the surrounding noise as it can. Think less about pointing the microphone and more about pointing the null. So if you have a microphone, if you know that you're going to get a lot of noise from more or less directly over the microphone, like a ceiling air conditioning vent or something like that, possibly something like a cardioid pattern is something to consider, because you'll be pointing your null more or less directly at the interfering sources. And the same is true if you decide to not hang the microphone but put a gooseneck microphone on a table. Sometimes like a hypercardioid or a supercardioid pattern points its null down towards the table. So that's a great opportunity for you to reject handling noise from papers and stuff like that.
And in that same environment, one of the big issues when people are recording these calls and playing them back is you hear people fumbling around with their laptops, and you hear people putting their cups up and down on the table, because that thumping is really exaggerated with the giant wood of the table as far as microphones are concerned. Are there any patterns that can help with that? Yeah, the table, typically it's a lower frequency sound that's coming from those. Buy them for aesthetics, for what it looks like in the room.
In general, you're going to want to match your sensitivity of them. Sensitivity is actually really critical, and low noise is critical too, because you'll probably be out the sensitivities of popular microphones and get a feel for what's reasonable.
For the way that the patterns work and the sensitivity.
Mouth will vary really dramatically, particularly with people who aren't used to using microphones. With a handheld microphone, have a tendency to let it tip. So we're at NAB 2017, and I'm showing off Countryman Associates' latest revision to their popular B6 microphone. This is threaded detachable connectors, so you can transmit. You can change the termination style from any of 400 different wireless transmitters to hardwired and back, and have a kit to make one of the world's most flexible lavalier microphones even more flexible.